Hello, class. Today we're talking about 8.3, geometry defined vectors and applications, basic terminologies, the equilibrium, incline application, and navigation application. So we're about to talk about some basic terminology. So if we look here, we have scalar. It's the magnitude of a quantity that can be represented by a real number. A vector in the plane is a directed line segment. Consider the vector OP. Now, O is called the initial point. That's where you start off from. P is called the terminal point. So, if you notice, on here they do what? They bold vectors. But since you can't really bold a vector when you're writing it, you can just go use the OP with the direction of the set line segment above it. So keep in mind that the initial point is O and the terminal point is P. So we have some more basic terminology. We have the magnitude, the length of a vector expressed as OP. So we look at the magnitude. They look like two absolute value bars. So when you find the magnitude, you should get a positive number. Two vectors are equal if and only if they have the same magnitude in the same direction. Now, we have vector OP, and then we have vector PO. Now, vector OP and PO have the same magnitude, but they have different directions. But if we look at the magnitude of both, they're equal. So let's look at these vectors. We have A is equal to B because they're going in the same direction and they are the same what? Magnitude. We have C is equal to D. They're going in both directions and they're the same length. We say A is not equal to E because even if they were the same length, they don't do what? They're not going in the same direction. A is not equal to F because what? They're going in the same direction, but they're not the same what? Magnitude or length. So make sure when you're doing these, you make sure you look at them real good. So the next thing we're about to start talking about is sum of two vectors. And in sum of two vectors, the sum of two vectors are also a vector. So when we look at the resultant, we say that we have vector A plus vector B is going to give us a resultant of A plus B. So it's two ways you can represent the sum of these vectors. You can have one going from an initial point to the terminal point and have one coming from the terminal point and have that share the terminal point with the initial point. As you see, vector A is coinciding with vector B. And then we have what? The hypotenuse being our what? If you think about it. Or the longest side being our resultant. Or we could do what? We can have it like a parallelogram and have both initial points start from the same spot. And then we take the resultant from the inside. It's the same thing. Either way, it should be the same. So take a minute and write this stuff down. Now, let's look at this. The sum of a vector V and its opposite, negative V, has a magnitude of 0 and is called the zero vector. To subtract B from A vector, you have to find the vector sum of A plus negative B, as you see illustrated right here. So take a minute and write this down. So it's really interesting on the direction because we see that vector A has a greater magnitude than vector B does. And we notice that the direction of the thing is going upward. So in this case, that vector will be longer than B, but probably a little shorter than A. If we look at that. Now let's start to look at scalar products of vectors. So when we look at scalar products of vectors, the scalar product of a real number k, which is going to be our scalar, all right, it says a vector u is the vector k times u, so k times vector u, all right, with a magnitude of k times the vector of the magnitude of the vector u. So if we look at u, u starts off what? Our normal set. Then we have what? We have 2u, which is double the magnitude of u. Then we have 3 halves, which is 3 halves the magnitude of u. Then we got 1 half, so it's half of u. If you notice, they get shorter, they get longer. Now we got negative 2u, which the negative changes the directions. Then you multiply by 2 to get the length. So it's double the length of u, but it's going in the negative direction. So take a minute and write this stuff down. Make sure if you have any questions, you are writing down your questions. Because that's your starting point in u. So you're just looking at them and you're comparing them. So let's look at properties of parallelograms. A parallelogram is a quadrilateral whose opposite sides are parallel. The opposite sides and the opposite angles are of a parallelogram are equal. All right, and the adjacent angles of a parallelogram and the supplementary are supplementary. All right, the diagonals of a parallelogram bisect each other, but do not necessarily bisect the angle of the parallelogram. So just keep that in mind. So now let's find the magnitude of the resultant. Two forces of 15 and 22 Newton act on a point in a plane. A Newton is a unit of force that equals about 0.225 pounds. If the angle between the forces is 100 degrees, find the magnitude of the resultant vector. So let's look at this illustration. Now, you're not always going to have an illustration. You have to draw this yourself. Now, the first thing they tell us that you have two forces that act upon a point. So they share point P. So let's look at this. We know that they share point P. So if you notice the resultant, we write the resultant from the middle, which we will use the resultant as V. So we will be finding basically the vector V. So take a minute and go ahead and write this. So we have the magnitude of v squared is equal to 15 squared plus 22 squared minus 2 times 15 times 22 times the cosine of 100. Well, 80 actually. It's 80 degrees because we're looking at the supplementary angle. Now,